do is you'll start with just practicing the operations, then it'll go into solving the matrix equations, okay? So the ones you guys have, and just to remind you of a few things, if you're adding and subtracting them, if they ask you to add or subtract two matrices, you have to make sure that you have to do the same dimensions first, like same number of rows, same number of columns. If because once it's there, guys, if I say add them, you literally just add the number. Okay? And when I say corresponding cell, right, the cell would mean like first row, second column. That's one cell. Right? Third row, fourth column, whatever. That's a cell. All right? So adding and subtracting would be a pretty easy one. Scalar multiplication is another one that's pretty basic. That just means that the scalar multiplication, guys, would be if you see something like a constant on the outside of a matrix. Maybe it was 2, 1, 3, 4, and I had a 5 out there. Remember, that's just saying multiply everything by 5. All right? So when I say scalar multiplication, that's kind of what I mean. The last one, this is, when you first do matrices and you start doing the operations, the multiplication is usually the thing that gets to people, at least for a while. With the multiplication, all right, remember that when you multiply them, you're going to check the dimensions first. But meaning that if matrix A was like a 3 by 4, and I wanted to multiply matrix B by it, if it was actually A times B, this number here, the number of columns for this matrix has to line up with the number of rows over here. So if B was like a 4 by 2, then I can multiply. Okay, because those two numbers right next to each other have to be the same. And if you remember, these two numbers tell you what the result's going to become. So if I had A being a 3 by 4, and B being a 4 by 2, after I multiply them, A times B is going to become a 3 by 2. Okay? Remember, the way you do it is you do the rows in the first one times the columns in the second. Okay? Okay, so guys, what we're going to do, hold on. Yeah, I'll do it. What I'm going to do, guys, I think I've got like 4 matrices up there. We're just going to do a couple of operations using them, if possible. Okay, because there are going to be some, in the homework, guys, that aren't going to be possible because the dimensions just don't line up. That kind of thing. All right, I'm going to write them out as we go, but those are going to be the 4 we're going to use. I wouldn't. You can write them out if you want, but they're going to be written out in the expressions anyway. All right, so the first one, we'll do
the first one first.
Start with an easy one. Yeah. Let's do
C.
do
A.
You mean just do A right there. No, we're not multiplying. We're going to start easy. Easiest thing would be scalar multiplication. Give me a number.
Oh, that's what you want to
4.
do.
Okay, so we'll do 4A. If I say here's A, you tell me what 4A is. What do you think it would be? And the problems, guys, are simply going to have 4A there. That'll be it. So your answers just has to be what the matrix will do. All right? So if I take A and multiply everything by 4, what's it become?
8.
0, 4,
Negative 12. Negative 8.
Gosh, guys,
All right.
like, oh.
Easy.
Oh, never mind.
We're really good.
Whatever.
Yeah.
You should just have this in your test.
All right, continue.
Test.
All right, next thing. We'll do the addition. That's the first thing would be, right, if you're doing addition, guys, first thing obviously would have to be, are the dimensions the same? Like, are the dimensions of A and the dimensions of B the same?
Yes.
Okay.
3.
So if I add those together, you get what?
3, 2, 5.
Minus -5.
Yeah, I got one.
-5.
5.
Would this change my answer? No.
Yeah.
No, not for addition. Okay.
Cumulative, right? I remember there's like properties, right?
Yeah, okay.
Adios,
So,
Mr.
whatever it is.
Gets kicked out of the college. You make me mad.
Yeah, no,
I should hear him in our history class. I'm just
Yeah.
kidding.
All right.
It's kind of funny, but he just says random things out of nowhere, like taking test meetings.
Okay, next thing, we'll do, matrix B times matrix C. Again, if it's possible, right? Because, that's a 2 by 3, correct? 2 rows, 3 columns? That's 3 by 2. So, 2 by 3, 3 by 2, I can multiply those, correct?
2 by 2.
Right? These numbers are the same, so that means my outcome here is going to be a 2 by 2. 2 by 2.
Thank you.
All right, so
Yeah, have a good
again, just to remind you, right? When you do the multiplication, it was you take the rows there, like first row, multiply it by the first column, meaning that you multiply, remember, each cell together and then add them. So that you've got 1 times 1. I'm going to write everything out first time. Okay?
Because we're just that slow.
Just to remind you, I'm going to ask where you get the numbers from. Okay? So again, first number by first number, second by second, third by third. All right. So again, remember the choosing of this entry is in the first row and first column. So to get it, I had to take the entire first row of that one, multiplied by the entire first row.
And you got one number after you add all those.
Yeah. So once you add that all up, you get one number, which will become 1 plus 0 plus 8, so 9. Okay. That's first. So over here, when I come this one, this is first row, first column. So first row, second column. Meaning now I'm going to take that entire first row and multiply it by the second column. So 1 times 4, right? Plus 2 times -1 plus 0. If you add all that stuff together, what does it give you? 2?
4.
Okay.
It's hard.
All right, now down to second row, first column, meaning I'm done with that row. Don't worry about it anymore. So, second row, first column, guys, will become 2 times 1 plus 0 plus 0. 0 times 2. Okay, which is -2.
It looks like an 8.
And then the last one would be second row, second column,
-8.
-8,
-1.
-1
0.
plus 0.
7. Oh, what was I saying?
That would be my answer there. Alright, so when we come back, I've got. Okay, so start with the next one. We will. Yeah. Yes.
How do
You
you
can't
do
do
these?
that one.
I can't do that one. Why not?
Because C doesn't have enough columns to multiply itself.
There you go.
It would be
So,
a 3 by 1.
that's a 3 by 2.
Yeah.
3 by 3. 2 and 3 don't match up, so I can't do that. What if I did that? You could do that. Then I could do it. Okay, so.
Wait.
Oh, it changed the answer.
Wait, Mr. Gordon.
Okay, so.
C is a 4. I thought it was a 2 by 3.
No, rows first. Alright, so guys, make sure all the stuff you check, the order matters with multiplication. That I can do because those didn't match up. But I can do it this way because now the numbers match. So when I go through this, that means that the 3 and the 2 right there tell me how big of a matrix I'm going to end up with. In this case, if I do D times C, I'm going to end up with a
3 by 2.
Okay, so going through everything, so that means I'm going to have 3 rows, and I'm going to have 2 columns.
Oh, that's how you figure it out?
Yeah.
How did you do my calculator?
How did you get those? You just said that you could do speed and then you could do column.
I could do CD back
Wow.
because if I flip flop the numbers, if I put D first, then the numbers will line up. Right? Change the dimension. Okay, so me multiplying these. Okay, so that means since D is first, that means the numbers I'm going to use in D are going to be the rows. So for the first one, first cell, this is first row, first column. So I'm going to take the first row of numbers, 4, 0, negative 2, multiplying by the first column of the other one. So it's going to be 4 times 1, right, which is 4, plus 0, plus 4, right? 4 times 1, 0 times 0, 2 times 2. Okay? Then since I've already got first row circled, we'll move over to the second column. So first row times the second column is going to give me this cell right here, because this is the first row, second column for a cell. So 4 times 4 is 16. Negative 1 times 0 is 0.
2 times 0 is 0.
Okay? Then move on to the next one. Okay, so I'm done with that row, so I'm going to move to second row now. So second row, first column, we have negative 1, 0. Okay. Second row, second column would be negative 4, negative 1, 0. And then what's the last one?
28 negative 5.
28, what? Negative 5? So the actual result, the final matrix there, guys, should be 8, should be 16, negative 1, that's 7, negative 5, and then 20. Okay? Okay, now, the last thing, guys, is going to be the matrix equation. Okay? 2 different ways you're going to see these. First way you're going to see the matrix equation. And guys, matrix equations means that you're going to be solving for variables like there can be x's and y's involved and so on, or maybe just solving for a matrix. The first way you'll do this is, like in this case, I'm giving you two matrices there. And then using those 2 matrices, I'm essentially I'm going to write out an equation. Just like I'll do 2x minus a b. All right? So all it's doing, so the x in this case, the variable, is going to be, my answer should be another matrix. Whatever matrix I get when I actually get x by itself, like normal. All right, and the way I would do that is, even if I was solving this out, just like a regular equation, like if I was getting x by itself, first thing I would do is add the a to the other side, correct? Okay. And then to get x by itself, I would just divide by 2. So and that's gonna tell you exactly what to do with the matrices I have. So I'm gonna add them up. Once I add them up, I've got everything in half. So with equations like this, guys, you solve them just like a normal equation. All right, so 1/2, what do I get when I add those two together? What is a plus b? What, 6?
6, 2, negative 4, 4. Yeah.
And then half of that is 3,
1, negative 2.
That would be it. So guys, if you see equations this way, this is the one where your answer needs to be a matrix. Okay, because A and B are matrices, if you got the variable sitting there, that means your answer is going to be a matrix. Alright? So that's one way you'll be doing like equation stuff and solving for variables. Alright? The other way. Hold on. Come on. Fast. You have it like set up. The other way would be things like this. Okay? Where, like, this one should be fairly straightforward and easy. Or that. Okay? So, like, guys, ones like this, it's just saying, look, X and Y are in the matrices. Okay? So just come up with some kind of equation using the cells that correspond. Such as, if I was doing the first one, what would X equal? 2. Because right here, that's in first row, first column. So it has to equal first row, first column there. This 2y right there is in first row, second column. So when I match it up over here, I'd go first row, second column, figure out what it is. I would get the same answer if I used that negative 6y, and that's it. Alright? Now look, the one down here, I wanted to do a different one. You do it the same way. The difference between them is instead of just setting them equal, now you just have to add or subtract something to it. So you're actually making more of what would look like a regular like linear equation kind of thing. So if I wanted to write an equation out for x, I would use, that's again, first row, first column. So I would use all the numbers in the first row and first column, which are x plus 5 equals 8, right? Those are all in the same spot, correct? Get x equals, is x equal? 3. And then what would I use for the y part?
First row, second column.
So what are 2y
plus negative 3 equals 5.
So y is
4.
how much?
4.
As long as you stay corresponding here, guys, good. And it doesn't, like on the first one, it wouldn't matter what I picked. I just used that x, because I didn't have to divide it. If I used the 2x there, I would have set it equal to 4. Divided by 2, I still will get the same answer.
Also, like, if you get x and y on the top row, you're not going to even more with
And if I didn't want to use the top one, but want to use the bottom one, I still would have got the same answer.